Hey there, AP Pre-Calc students. Can you believe we've made it to the very last lesson in Chapter 3? This is Miss Adams from Flamingo Math. Join me today. We're going to look at rates of change in polar functions. Because just like any other function we've studied, we can analyze polar functions for their key characteristics. Let's jump right in and consider the curve 5 sine theta on the interval from 0 to pi. What's the maximum distance from the pole, and where does this extrema occur? One more time, I'm correcting my mislabeled axes on the graphs to be r and theta for the x-axis and the y-axis. Well, we know that we have a maximum at 5, and that maximum occurs when the angle is pi over 2. So we could write that r theta as 5 pi over 2. For what values of theta is f of theta equals 0? We can solve that. 5 times the sine of theta is 0 whenever the sine of theta is 0, and that happens when theta is 0 or pi. In part C, we want to describe the behavior as theta approaches this maximum from the left and the right. So we know from the origin our function is moving around this way. We get up here, this is our maximum value at 5 pi over 2. So from the right, f of theta is increasing. We get up to the maximum, and then at the maximum, f of theta is going to be decreasing. So we want to write that in a sentence here for part C. I've made that statement this way. As theta approaches pi over 2 from the right, the y values are increasing. But those y values change from increasing to decreasing at our maximum for all the angles greater than 0 up to pi. And you can see from both sides, from the left or the right, the y values are getting closer and closer to 5. But as you trace the graph around from 0 all the way back around to pi, those y values increase, there's a maximum, and then the y values decrease. So you want to be careful with your language here. Let's summarize our findings in the table on the next slide, considering that function value, the value of the radius for the curve. Is there an interval where the radius is negative? And explain why or why not. So we just kind of basically said that all the values of the radius are greater than or equal to 0. None of them are negative. And they complete one full cycle in pi radians. On that interval from 0 to pi. And then here in the chart, if theta is our angle in this first column between 0 and pi over 2, and then between pi over 2 and theta, is r positive or negative? And we just said in both cases they're both positive. And in the first interval, is r increasing or decreasing from 0 to pi over 2? And we see it was increasing. But from pi over 2 to pi, that's where it begins to decrease. And then what happens to the distance r from the pole? In this first interval, the distance is increasing. It's getting closer to 5. And then in the second half of the graph, the distance from the pole is decreasing. It's getting closer and closer to the pole. So we're looking at rates of change as they're related to polar curves. Let's consider the curve r equals 4 cosine 3 theta on the interval from 0 to pi. What shape is this polar curve? And then can you sketch that curve on the right? And we know that from the earlier lessons, 4 cosine 3 theta is going to be a rose curve. It's going to have 3 petals. It's going to be centered on the polar axis for part B. So we got polar axis symmetry. If we start here at 4, 0, we're going to have another point at 2 pi over 3 and one at 4 pi over 3. That's going to be down here. So equally spaced. Here, down to the first one, up to the second one, and then back to our original. So we got 4, 0. We got negative 4 pi over 3. And then we have 4, 2 pi over 3. For part C, what is the maximum value of R? And how do you know where do these maximum values occur? We know that the absolute value of R has to be 4. That's our A value. And we know that theta has to go between -1 and +1. So cosine of 3 theta is going to be 1. That maximum is going to occur when theta is 0, pi over 3, 2 pi over 3, or pi. So we saw that at pi over 3. We saw it when we started at 4, 0. We saw it again at 4 pi. We saw it at pi over 3 and 2 pi over 3. Then part D, for what values of theta is f of theta equal to 0? We want to solve our argument. Where is the cosine of 3 theta equals 0? Well, we know the cosine of theta is 0 at pi over 2, at 3 pi over 2, at 5 pi over 2, and at 7 pi over 2, because I'm thinking about the domain. If we have 0 is less than or equal to theta is less than or equal to pi, and we multiply each term by 3, we've got to go from 0 to 3 pi. So these values in here would do that for us. And then dividing each term by 3, theta would be at pi over 6, we're at 0. At pi over 2, we're at 0. At 5 pi over 6, we're at 0. And then 7 pi over 6 is outside of our original domain of pi. In this example, we want to test values on each interval of theta to determine whether the radius of the curve for r equals 4 cosine 3 theta is positive or negative for each interval. And then we want to decide is the corresponding point farthest from or closest to the origin. So I've set up my test intervals here. This is the value of r that we're going to test. And this is the behavior of the y values there. So this first one starts at r is 4 and theta is 0, so 4 theta, and we're going to move toward the origin. So in between 0 and pi over 6, if I put a value in there, that value is going to be positive, but the behavior is decreasing. And then between pi over 6 and pi over 3, if we test a value in there, you see that the y values are, the values of r are negative, and we are decreasing. And then in the next interval, the values of r are still negative down there, but our function is increasing. And then the values here in between pi over 2 and 2 pi over 3, the value of r is positive. The behavior is increasing. In the next section, our values are still positive, but the distance is decreasing back to the origin. And then finally, in our last stretch, the values of r are negative, but the distance is increasing. So here we have a maximum. In the second one, let me erase a little bit. Get rid of this. So I was using this stuff here to evaluate. Here we had a maximum, then we had an intercept, then we had another maximum out here, we had another maximum here. So I'm farthest from the origin at those values, at 0, at pi over 3, at 2 pi over 3, and again at pi. And we're closest to the origin at pi over 6, at pi over 2, and at 5 pi over 6. You can see those are my zeros at the origin. And these are the maximums at 4, -4, 4, -4. We're going to continue looking at that same curve. Use the information from our previous example. We can further analyze the polar curve. So let's talk about on the interval from 0 to pi over 6. Is r positive or negative? So r was positive in that case. And the r, is r increasing or decreasing? Well, it was decreasing because it was going back to the origin. So that means the distance was decreasing. And then in the next segment, the r value was negative, and it stayed negative through the next interval. The r value was decreasing, and then it changed to increasing. So the distance from the pole was increasing here and then decreasing in the next interval. And then at pi over 2 to 2 pi over 3, the r value was positive. It stayed positive. The r was increasing in this first interval, and then it became decreasing. And you can see that if we get our highlighter out, you can see that in here we were going back to 0. And here we were going back to 0. So at pi over 6, we had a 0. At pi over 2, we had a 0. And at 5 pi over 6, we had a 0. So these were all, this was a 0, a 0, and a 0. In the next section, for pi over 2 to 2 pi over 3, r was positive, but it was increasing, so the distance from the pole was increasing. That made 2 pi over 3 was a maximum, just like pi over 3 was a maximum, and 0 was a maximum, and pi was a maximum. In this next section, we were decreasing because we headed back to 0, and then we were increasing, and the r values were negative here, and they were decreasing, but the distance from the pole was getting larger. So we want to summarize all of those findings. Get a highlighter a minute. I want to highlight this. We had maximums here, and here was a maximum. This was a maximum, and this was a maximum. You can notice how we changed from decreasing, increasing to decreasing, increasing to decreasing, increasing to decreasing. Then for part B, explain how the table can help you identify the angles. If you look with me, when r changes from decreasing to increasing, when r changes from decreasing to increasing, a maximum occurs. When r changes from increasing to decreasing, a maximum occurs. We could also say, I don't have room to write it, but we also could say, when the distance from the pole changes from increasing to decreasing, a maximum occurs. Increasing to decreasing, a maximum occurs. So that's how we could use the chart to help us analyze the function. And finally, let's give the polar function. We're going to summarize this same example here. If the R values are positive and the function is increasing, then the distance from the origin is increasing. And you can use that previous table to find that. When the R values are negative, the distance from the origin is decreasing. When the function value is increasing. So we're looking back at the table to figure this out. And then finally, when the R value is positive, and the R value is positive, so where would that be? That would be in 0 to pi over 6. And R is decreasing in that same interval. What happens to the distance? The distance is decreasing. And then where the R values are negative, so I'm looking at where the R values are negative and the R is decreasing, what happens to the distance from the pole? It's increasing. So I could see that in the table from pi over 6 to pi over 3 as an example. And I believe that's the end of this section. We have one more section tomorrow to finish up Unit 3 in AP Pre-Calc. See you there.